Hello everyone. In this lecture, I'm going to cover chapter 13, recursion. Basically, in this chapter, we're going to talk about the concept of recursion and how to solve a problem using a recursive method, and how recursion is different from uh, iteration and iterative methods. So in order to understand the concept of recursion better, we need to first start with a simple and easy to understand example. We start with the example of triangle numbers. A triangle number, or the nth triangle number, is the area of an isosceles right triangle with the edge size of n, and the triangle is made of open and close bracket squares. And each of these open and closed brackets has an area of 1. So the area of a triangle with edge size n is called the nth triangle number. For example, the third triangle number is 6 because it's made of 6 different squares. As you see, these 6 squares will generate a isosceles right triangle of edge size n. Let's assume that we are going to model the triangle class in Java. How can we do this? We have to start with writing an instance field for it, which is an integer of width, which stores the width of that triangle. And then the constructor of the triangle gets a width and assigns width equal to a width. This is basically the initialization of the only instance field that triangle class has. And then we have a method which is public int getArea, which basically has to return uh, the area of the triangle, which is the nth triangle number. So we're going to focus on this method and see how recursion help us write this method easier. In order to write down the method of getArea using recursion, we have to first consider the exceptional case, or consider the extreme case. The extreme case is when you have only one single square and the triangle consists of that single square, which generates the first triangle number. The area is obviously 1 because it consists of one single square, and basically you need to take care of that extreme case in the first line of getArea method. You say if width is equal to 1, then return 1, which means if the exceptional extreme case happens, then return 1, because the area of one single square is 1. The second step of writing a method using recursion is to handle the general case. In fact, you have to assume that we know the area of a smaller triangle with width n minus 1, and see whether or not we can find out the area of a triangle with width n. So it means that assuming that you can calculate the area of this blue triangle, will you be able to calculate the area of a bigger triangle that is constructed by adding one more row of these black um, brackets to it, or not? Basically, we know that the area of the larger triangle can be calculated as the smaller triangle plus the width of the larger triangle. For example, this larger triangle consists of a blue triangle which has the area equal to 6 plus the width of the larger triangle, which is 4. So the area is 6 plus 4, which is 10. So if you count all the triangles here, all the squares here, you see that there are 10 open and closed brackets in this figure. So in summary, in order to get the area of the triangle, you have to apply the same method of getArea to find the area of the smaller triangle. And after you find the smaller triangle's area, you have to add it with the width of the larger triangle, which is stored in the only instance field of the class triangles. So here is the code for the general case. First, you say, let's assume that we create a smaller triangle by this constructor, new triangle width minus 1. So you first create a triangle with the width equal to the original width minus 1, and then you apply the same method getArea on the smaller triangle to find the area and store it in an integer like a smaller area. And finally, you have to apply this summation, smaller area plus width, to calculate the area of the original larger triangle. So far I have shown two steps. First step was handling the exceptional case, the extreme low, and second, handling the general case, which means calculating the area of the bigger triangle or the larger triangle by calculating the smaller triangle's area first. So this is the whole implementation of the getArea using recursion. We say if width is equal to 1, then return 1. That's taking care of the extreme case. In the second line, we create a smaller triangle by this code. Triangle, a smaller triangle is equal to new triangle with the width of width minus 1, where width is the width of the original triangle, but you need to subtract 1 from it to get a smaller triangle. Then you have to apply the getArea inside itself. So you see we are defining getArea, but inside the definition of getArea method, inside the implementation of getArea method, we are calling getArea itself. That's what makes this solution a recursive solution. So a smaller triangle calls the getArea method again to find out the area of the smaller triangle that we created in the previous line. And in the last line, you simply say return the smaller area that is calculated by getArea method itself plus the width of the original triangle. This way, you are returning the correct number as the area of the larger triangle. So let's see how the method that we implemented works and is executed when you want to calculate the area of a triangle with width 4. In the first step, it creates a smaller triangle with width 4 minus 1, which is 3, and it calls the getArea method to find out the area of the smaller triangle with width 3. Then inside that getArea method for triangle of size 3, it calls the method again for a triangle with width 2. In fact, that method first creates a smaller triangle with width 2, and then it calls the getArea on that triangle. Again, when you call that getArea for triangle of width 2, it again subtracts the width by 1 and constructs a smaller triangle with width 1. Then it calls the getArea for the triangle of width 1. Now, this time, the getArea method doesn't call itself because the triangle is small enough, has width 1. If you remember from the previous slide's implementation, in the first line we have an if statement that if the width is 1, don't call getArea again, simply return 1. So the method returns 1. Now, the method of the last getArea method that is called returns 1. Now, when it returns 1, this the previous getArea method, which was called before for a triangle of size 2, returns the smaller area plus width, which is 1 plus 2, which is equal to 3. So the method that is called for triangle of size 2 returns 3. The method that was called for triangle of size 3, triangle of width 3, returns a smaller area, which is 3, plus width, which is 3. 3 plus 3 is 6. And finally, the original method, the original getArea method, which we called it for triangle of size 4, triangle of width 4, returns the smaller area plus width, which is 6 plus 4, which is equal to 10. So 10 is the fourth triangle number that is calculated in a recursive manner in the following way that you saw. So in summary, we can say that a recursive computation solves the problem by using the solution of the same problem with simpler values. So in fact, when you want to use recursion to solve a problem, you have to be able to solve the smaller problem using the same solution, and then use the solution for the smaller problem to construct the solution for the bigger problem. For recursion to terminate, there must be a special case or special cases for the simplest inputs. So finally, we have to reach to a special case, and that special case should be solved in a very simple way without calling the recursive method again. In the triangle example that we saw, we can also handle an exceptional case in which the width of the triangle is not positive. If the width is less than or equal to 0, you simply return 0. That's for basically handling the exceptions. And if we want to summarize the recursion process, we can say there are two big requirements for the success of a recursive method. First of all, every recursive call must simplify the computation in some way, or in other words, we can say every recursive call must reduce the size of the problem. Okay, and the second requirement is this: there must be some special cases that handle the simplest computations directly without calling the recursive method again. So in the triangle example, we had the first if statement which handles the special case, and we had the following lines of codes which handles the general case and simplifies every triangle by reducing it to a smaller triangle with width equal to width minus 1. Now let's see whether or not we can calculate or compute the triangle numbers in different ways. Basically, since we want to find out the triangle, the area of a triangle which is constructed by a number of brackets, we can calculate the area by simply adding the number of brackets or the number of squares in each row. In the first row, we had only one brackets. In the second row, we had 2 brackets. Third row, we had 3 brackets. In the last row, we had width number of brackets. So the area would be the summation of all of these numbers. This summation can be calculated using a simple loop. You can first initialize a double variable like area equal to 0, and then in a for loop with the counter I, from I equal to 1 to I equal to I less than equal to width, you can simply say area is equal to area plus I. After this for loop finishes executing, then you have area of the whole triangle. And then if you want to use mathematics, you can also simplify this summation as n times n plus 1 divided by 2. This formula is a very famous formula that everyone knows if you know some basics about algebra. So therefore, you can simply say the width of the area of the triangle is calculated by this formula. Width times width plus 1 divided by 2. Instead of writing a for loop or instead of writing a recursive function or recursive method, you can simply return this simple formula. Width times width plus 1 divided by 2. As another example of recursive method and solving a problem with recursion, we want to find out whether we can write a method to see whether a sentence is a palindrome or not. A palindrome is a string that is equal to itself when you reverse all characters. For example, if you read the sentence, a man, a plane, a canal, Panama, from right to left, you get the exact same sentence. A man, a plan, a canal, Panama. Same for these two examples. You want to find out whether we can write a method that can evaluate or check whether a sentence is a palindrome or not. But we want to do this using a recursive method. We want to think recursively instead of writing a for loop. First of all, we need to create a class like sentence, public class sentence, and that class must have a private string text, which stores the text itself, and it has a constructor that gets a string text from the input parameter and sets text equal to that explicit parameter. Then inside the sentence class, we need to write down a method that checks whether the sentence is palindrome or not. Public boolean is palindrome, which gets no input parameter, no explicit parameter. And inside this method, we have to check whether that sentence that is stored in the private instance field of the class is a palindrome or not. But we're going to do this using recursion. So first of all, you need to think how to simplify the input, or in other words, how to break the original problem into a smaller problem that can be solved in a similar way as the original problem. You can think of several possibilities. For example, you can see whether removing the first character can create a subproblem that can be solved in the same way that the original problem is solved. Or can we remove the last character and simplify the input? Or can we remove both the first and last characters? Or can we remove a character from the middle to simplify the input? Or can we cut the string into two halves? We're going to think about different possibilities and see how to reduce the size of the original problem and attack the subproblem in the same way that we attack the original problem. So if you think about those possibilities, the most promising one, the most promising simplification is when you remove the first and last character. Why? Because, for example, if you have a palindrome like Madam or Madam, if you remove the first M and last M, the result, which is this string, is still a palindrome. Therefore, a word is a palindrome if the first and last letters match and the word obtained by removing the first and last letters is still a palindrome. So this means that the best or the most promising simplification is to remove the first and last characters, because if you remove the first and last characters, you we'll obtain a string which is first shorter than the original string, and that string would be palindrome if the original string is a palindrome. Obviously, since the sentence that we get in the input can have other characters, other non-alphabetical characters, you can simply ignore them if you see them and check the next character. So if the first or last character is not a letter, you can check whether you can simply remove them and test the shorter string. So as I said before, you need to think about the simplest form and try to solve the problem for the extreme simple case separately and directly without the help of any other recursive method. So in this example, the simplest cases or the extreme cases are either when you have a string with one or no character. If you have a string with a single character, it is a palindrome no matter what. And if you have a string that is empty, an empty string is also a palindrome. So you need to take care of these exceptional and extreme cases at the beginning of the method using an if statement. So here is a detailed implementation of is palindrome in Java. First, you have to say that calculate the length of the string, which is text.length. If the length is less than or equal to 1, which means that we have an exceptional case, the extreme simple case, you need to return true. As I said, a string with one or no characters is a palindrome. Then you need to find out the lowercase form of the first character and set it into first, and lowercase form of the last character and you set it equal to last. So first and last contain the first character and the last character of the input parameter or the input sentence. Then you need to check whether both characters, the first and last, are letters, are alphabetical letters. If they are both letters, then you check for their equality. Basically, you say if they are equal, then you have to create a shorter sentence which only contains which doesn't contain the first and last character. So you basically cut the first letter and last letter of that sentence and you create a shorter sentence like this. Basically, you need to call the constructor of sentence class for the substring of text which starts from index 1 and ends before length minus 1 index, before index length minus 1. So this way you're cutting the first and last character of the sentence. And then after constructing the shorter sentence, you simply return shorter that is palindrome. Basically, you're saying if the shorter sentence is palindrome, the current sentence is also a palindrome. But in the case that the first and last letter are not equal, you don't waste time, you simply say return false, because you don't need to check the rest of the sentence when the first and last letters are not equal. It means that it's not a palindrome. Now, let's assume that either the first or the last sentence or the last letter of the sentence is not a letter, is not an alphabetical letter. For example, if the last letter is not a character, then you simply remove the last character by applying the substring method and set it equal to a shorter sentence, and you return shorter than is palindrome. So you're basically skipping the last letter which is not a character. Otherwise, we have shorter, the case in which the first character is not a letter. In that case, again, you need to use the substring method to eliminate the first character, which is not a sentence, and again call the is palindrome for the shorter sentence. That's the end of the method.